Okay, so this is lecture number 3. So yang lecture number 2, I hope you can go and watch the video. It's only introduction to the user interface. Okay, so the foundation or the content of this course is mainly discussed in this session, which is the modeling. So we have modeling 1 and modeling 2. So we will cover modeling 1 and 2 today. Okay. So last week we have looked into what are the motivation, what are the main problem that we are trying to address in this course, and then based on that we are looking at all the processes involved. Okay. So when we're dealing with information retrieval, basically we are looking at how do we manage the document, how do we store them, how do we represent them in the storage, and then how do we retrieve them, right? Okay. So today we will look at the basic overview. How do we model document? It's more like how do we store them, how do we manage them, and then how do we retrieve this document based on the keyword given to us. Okay. So today we are here just to look at where we are at the moment. So last 2 weeks we covered this one, and this one is the video. So today we'll cover this. This one cover a bit more because there are the 2 parts here, modeling 1 and modeling 2. Okay. So we will cover that one today. Okay. So this is the overview for today. So for the modeling part 1, so we will introduce the IR model, the basic concept when we want to retrieve a document, and we will start with the Boolean model. We have the term weighting, and then the vector and probabilistic model. Okay. Okay. Modeling in IR is a process aimed at producing ranking functions. So the whole idea is we have this document, okay, all this document, and then we want to store them in storage, okay, and then later on we want to retrieve this document, and we will display the ranking of that document. Okay, so that is the whole idea. Is how do we store them, represent them, and then how do we store them in the memory, and then how do we retrieve them? How do we actually say some documents are relevant and some documents are not relevant, and we take this relevant document and how do we perform the ranking function? How do we rank the document based on the keyword that we have? Okay, so that is the end function that we want to do. So the ranking function here is a function that assigns score to documents with regard to a given query. So given the query that you have typed, we want to rank the document. So we use this ranking function. So this one we can use the cosine function or the Euclidean distance function and so on. Okay. So this process consists of 2 main tasks, which is how do we represent the document, which is this one. How do we represent this document? And then how do we quantify the similarity or differences among the document and query? So these are the main gist of this information retrieval. How do we conceptualize the logical framework to represent document and also at the same time query? So both must have the same framework because later on we want to quantify the similarities or the differences between document and queries. So this is the IR model that we are talking about. So in earlier work, they used this index term to represent or to index and retrieve the document. So based on the index term, they will retrieve the document. So this keyword produced based on the person name, the concept, or the place or the idea. Okay. So in more general form, it is any word that appear in the document, but it must be able to describe the content of the document. Okay, so our keyword cannot be too very general. It must be very specific to that particular document, so that you will be able to retrieve that document later on. Okay, so since we have so many documents, we must be able to minimize the number of keywords that used to describe the document. Okay, so retrieval based on index term can be implemented either efficiently, since index terms are simple to refer. But we cannot have too many of these keywords because it will populate our memory. Because later on, the idea of conceptualize the representation of document is based on document and index term. Okay, so we must have to reduce the number of keywords to represent all the document. So for example, like this is the document that we have, and this is your query. So what happened is that they want to do the or retrieve the document based on the similarity of the index term here. And then we will pull out this document and then we perform the ranking. Okay, so the ranking is just an ordering of the document that reflects their degree of relevance with respect to the user query. So basically, it depends on the content of the document. Okay, so as a result, IR system deal with the problem of predicting the relevancy of the document. How do we quantify the degree of relevancy of each document that we have in the database with respect to the query that you type? Okay, and this problem naturally embodies the degree of uncertainty and vagueness. Means there is no clear cut saying that this document is very relevant or not relevant. So it depends on the calculation that we have. Okay. So how do we model information retrieval? So in here we have a quadruple entity. So quadruple means we have 4 entities or 4 main components. So the first one is the D. The D represent a logical view for the document in the collection. So how do we represent the document in the system? How do we coding them? How do we design a data structure to represent them? Okay, and at the same time, we also have the query. So the query is similar to D. They must have the same logical view. Otherwise, we cannot compare. Okay, so we must have 2 parts. The first one is document. Second one is the query. Okay, and the F is a framework for modeling document and query. So how do we put these 2 together so that we can quantify the similarity between the document and the query? And the last one is the ranking function. So the ranking function should be able to rank the document based on the query given to you. Okay, so this is a set of document, a set of query, and then we must be able to represent them. Logical view means it's coming from logic, right? So it should be binary format, okay, or higher order, which is numbering. So based on this, then we can quantify the ranking of the document based on the query. So this is the model that we're going to have. This is the general one. Of course, there are so many ideas. How do we represent them? And then how do we perform the ranking and so on. Okay. Okay, when we look at the taxonomy of the IR model, so basically nowadays we have text, or we have link, or we have multimedia such as images, video, audio. So to look it like a foundation of this course, we are looking at the text only here, which is the text, which comprises 80% of the unstructured data that we have. Okay, so we will look at these two, and then when it comes to the Boolean, we have this set base, we have the vector also, we have all this. So what we will do is we will cover this two. Okay, so we will not cover this. Okay, so this one is just to differentiate between ad hoc and also filtering. So the ad hoc is general, where you can put up your question, your query, and then we are looking at the collection of document that we have. So everybody will get a general overview, and everybody will be treated as general user. We cannot differentiate the profile. Okay, but for the filtering, it filters the document based on the user profile. Okay, so all this while we use Google, right? So when we use Google, then if you notice, sometimes we log into the Google while we're browsing using any browser. So when we do the Googling, they will build a list of history for the keyword that we have typed, and they will do profiling for us, which is they will build a profile that represent you, and they have the list of keyword that you have asked, and then based on your previous query or previous keyword, they will try to rank the document based on your profile. Okay, so these two are different because this one is more efficient because they are giving you more relevant document with respect to your profile. They will try to match with your profiling. Okay, so for example, bank. Okay, so it could be going to the financial or go to the bank of river bank. So if you are people from financial, so the bank here referring to something related to financial domain. But if you are someone who work in the forest or biodiversity, so the bank here may be referring to the bank of river. Okay, so that's the use of filtering. Okay. So to represent the document, the basic concept here is that each document will be represented by a set of keyword or index term. Okay. We cannot use as many as possible because it will populate our index list. So what we want to do is we want to choose keyword sufficient enough to describe the document. We do not want to have so many keywords that describe an individual document, because later on when we have so many keywords, then the calculation will be very time consuming. Okay, so when we say index term, it refers to the word or group of consecutive word that we have. Group of consecutive word means we have more than one word for the index term. For example, computer science, that's two words, software engineering, network engineering, and so on. Okay. So a pre-selected set of index terms can be used to summarize the document. So we can use this index term or set of index term to summarize the document. However, it might be interesting to assume all words are index term, full representation. So meaning that we take as all, but not too many to represent them. Okay. Okay. For example, let's suppose we have T to be the number of index in the document collection. So that means we have T number of keyword. So we will have something like this, where we start from keyword 1 up to keyword T. So we have T number of index term or T number of keyword. Okay. So we just imagine that we have T number of term that we have in our dictionary. So our vocabulary will be represented as V, and we have a vector of keyword 1 up to keyword T. So we will have this. Okay. So that's why when I said we want to represent a document using keyword, kan? So we do not want to use up so many keywords to represent a single document, because kalau kita ada 1,000 document, then each one of them will have different keyword, then our list will be larger, our T will go bigger. Okay. So we want to optimize this, because later on, when we want to perform the ranking function, we want to have efficient calculation for the ranking of the document. We do not want to use all the memory. So the objective is to optimize the number of keywords that we have in our vocabulary. Okay? So this vocabulary is used to represent all the document in our storage, not only a single document. Okay? So contohnya kalau document 1, they may consist of keyword 1, but not consist of keyword 2, consist of keyword 3, and may not consist of this. So another document may have this keyword and this keyword, but not this one. Okay? So this is what we call the logical view, because we are using binary to represent them. Or we could use a number. Okay, so we will go further on how to define this. Okay, but the objective is to optimize this, to get the number of keyword that is good enough to represent all the document. We do not want to list so many keywords for all the document. So that's one of the issues that we want to address. Okay, so like I mentioned just now, when we have this vocabulary up to K up to T, so that means we have this pattern here. So that means we have 2 to the power of different number of pattern. Okay, so pattern refer to different form of binary here. Okay, so each of this pattern of term co-occurrence is called term conjunctive component. Term conjunctive component, because we are saying that this is a combination of a few terms. So this is 1, this is 2, this is 3, and so on. Okay, so for each of the document that we have ataupun query, we associate a unique term conjunctive component, which can be represented as this. So when we have this, so that means all of this conjunctive, we have n here. Okay, but this one must be not. So this term conjunctive component referring to a combination of binary, which is combined using the operator and conjunctive. They use the and operator. Okay? So when we actually represent this, so this is document 1, this is document n. So document 1 actually have this term conjunctive component. Okay, so if we have only one, so this is this, and this is n. So for this expression to be true, this one must be negated. Okay, so we need to take the complement of k2, which is if not 0 is equal to 1. Okay, so the not false is true, right? Okay, so this is not false, and this is true. So by having this, so this expression will become true. So similar to the dn, we use the and operator also. Since all of them is 1, so you do not have to take the complement of this. Okay, so this one will become 2. Okay, so this is how we represent the document in the basic concept. We use binary to say that this keyword exists in the document. Okay, so in order to represent the document, we use the term document matrix. So we say that the occurrence of term ki in document dj establishes a relation between ki and dj. So here we have the keyword, we have this document here, and this one telling you the existence of this keyword in this document. So it could be binary or any other number. Okay, so this is what we call the term document relation between the keyword and also the document. Okay. So this is in a matrix form. So where each of these elements stand for the frequency of keyword I in document J. Okay, so the keyword 1 in document 1. Okay. Any question? Boleh gak?
Morning, Prof.
Ya.
Yang dia punya column tu always document kah? And then the keyword always rows ataupun dia boleh transpose?
Dia boleh transpose juga. So sometimes the document ni on the raw side and sometimes the keyword in the column side. Boleh juga. As long as they have clear indication what is raw, what is column. So sama juga.
Okay, Prof. Thank you.
Okay. So, but it says term document. So normally we say row and column, kan? So depending on. But sometimes they say document term. So document terms, that means the row is document and term is the column. Okay. So the problem in the IR domain is that whenever we have this document, all the document, we must build this keyword. We must build the vocabulary so that for each of the keyword that we have, we can quantify them for each of the document that we have here. So quantifying them, we can say we are looking at whether this keyword exists by using the binary 1 or 0, or we could use how many times they appear in that document, which is the frequency of keyword 1 exists in document 1. Okay. So that's why before we can go up to here, or the taxonomy of keyword, which is we want to build this list. Okay. So what happens is that we have the document here, then we have to know the text structure. The text structure meaning that what is the title, who is the author, what is the introduction part, and so on. So based on that, then we can extract the content of the document, okay, and then we will perform some of the removal. For example, we remove the spacing or assign, or we remove all the stopwords. Okay, the stopword here referring to all the term that is not carrying any meaning. For example, the of, and so on. Okay, so this is the stopword, and after that we also look at all the noun group. For example, person, idea, or address, or some kind of name. So we all put here. Okay, and then we also do the stemming in order to reduce the number of terms. For example, the stemming is finding the root of the word. For example, we have place. Okay, and also we have player. Okay, and also we have playing. So all of these, if you find the root of the word, we have play. Okay, so stemming is finding the root word of each of the word, and we do not want to have a duplication, so we just use play here. So we don't count these two things as two different terms, two different keywords. Okay, so that is the stemming part. Okay, stopword is just to remove the term that carry no meaning. So by doing this, we are optimizing the vocabulary that we have. And finally, we have this. Okay, so this is a very tedious work, but I'll show you in the practical on how to do this one, because they have a built-in library that can remove all the spacing, funny character. They also have function to remove the stopword, function to do the stemming, and so on. So this is to build the taxonomy keyword, which is optimized. Okay. Any question so far? Okay,
No
now
question.
we go to ada soalan? Okay, now we go to Boolean model. So yang tadi itu is general only. They say, okay, this is how we represent the document. We use term document to represent all the set of document that we have. Okay. So this is the first model that we have. They use binary, because Boolean model, they refer to true and false, 1 or 0. So that means they are looking at whether that keyword exists or not in the document. Okay. Okay. So in the Boolean model, they are this is a very simple model based on set theory or Boolean algebra. So Boolean algebra meaning that we use true, false, and we use this N. This is the N. This is the O. And this is the negation, which is the complement of this symbol. Okay. So when we look at this expression, the query here, we are looking at, I'm looking at document that consists of keyword A and keyword B, or not keyword C. Okay, so for this expression to become true, so because this is N, so this one must be always 1, and this is O, so, and this is negation of this, so we could use 1, 0, or 1, 1 or 0, 1. So basically we have this combination that will fit our search. So we are looking for a document that have this pattern. Okay. So you understand kan how to. Okay, so we are looking at document that consists of this pattern for this key query. Okay, so meaning that so the for weight is the weight of this keyword lah. So the weight is between 0 and 1. So we are looking at this keyword will no the relation between this could be 0 if the keyword does not exist in the document. Otherwise, it is 1 exists where ki exists in document J. So for instance, this is our query and this is our vocabulary. So like I mentioned just now, we are looking for this document. This one or this one or this one. So we are saying that we have this this is a conjunctive component for Q. So this is where? Yeah. So a term conjunctive component that satisfies a query is called a query conjunctive component. So that means a query rewritten as disjunction of those components is called disjunct normal form. So this is the disjunct because they use or here to combine the conjunctive component, the query conjunctive, because we mentioned here we have 3 patterns that we are looking at, either this or. So each of this is called conjunctive component, but when we combine them, they are called the disjunct normal form. Okay. So this is the expression that we are looking for this query. So when we look at the space, the search domain, we are looking at this area, the blue color area. So as long as the document fall within this range or region, so we retrieve all this document. Okay. Okay, let's suppose we have 4. Now we have 4 keyword. And then we still using the same query yang tadi tu. Okay. But if you look at here, since our query do not have D, we do not have this. So for us to retrieve the document, we don't care whether that document consists of keyword D or not. So for that reason, we will include all the expression that consists of KD as 0 or 1. Okay. So if you go back to the previous slide, this one. So basically we have this and we add 0 and 1. And we have this, we add 0 and 1. This is for the KD. Yeah? So this is. So at the end, we will have 6. So if we put forward, so that means we add this and this. This is for the KD because we don't care whether we have KD or not have KD, as long as this one stay. So this is the additional. Okay. So imagine that we expand this one to 1,000 features or 1,000 keyword. So you will have longer lists, right? So we want to minimize the number of features that we have here. Okay, so that's how we represent the query, and then we are looking for the pattern that will retrieve the document consisting the keyword that we have here. Okay. So how do we measure the similarity here? So we are looking at the exact matching here. So the similarity of document DJ to the query is defined as, okay, so the similarity is 1 or 0. That means all the document that consists of this pattern will have similarity index score as 1. If they do not match, okay, the query is in the disjunctive normal form because we could have more than one document. Okay, but for each document too, they are represented as conjunctive normal form because each document will have one format only, right? But for each query, they may have different format that can match the expression. Okay, so each of the query will have disjunctive normal form. Each of the document will have the conjunctive normal form. Yeah, you are right. Okay, that's answering your question, Dr. Jekyll.
Yes, Prof.
Okay. Okay, so in searching for the document, we have to find the matching here. So all those documents that match, when we compare, the result will be 1. Not match, the result will be, if not matched, 0. So you look at this, so all the documents that we retrieve will have this similarity as 1, right? So matching only. But the problem with this, we cannot do ranking because let's suppose we have all 6 documents we managed to retrieve, but all of them will give us 1. So that means there is no ranking. We only retrieve relevant document, but no ranking score that can be computed. Okay. So when we say we are using the Boolean model, retrieval based on binary decision criteria with no notion of partial matching, because we want to have exact matching of the binary, the pattern. So no ranking can be performed because we only have 1 or 0. So if we have retrieved 6 documents consisting of 1, so we have all the scoring as 1. Okay? So information need has to be translated into Boolean expression, which most use find output, means we only use binary or 0 and 1. We cannot capture the how many times that would exist and so on. Okay, it's too simple. Okay, the model frequently return either too many or too few or too many documents, because if they match, then we will give. If not match, then we will not give. Okay, so for that reason, the Boolean model is not sufficient enough to retrieve document very efficient, because it will give you everything without any ranking, or they will not give you anything because no matching, because they use exact matching of the pattern. Okay. Okay, for that reason, they say, okay, why not we replace the binary number with the term weighting? Term weighting is considered as a score that they use to weight the term. How important is the term in the document? So this one can we can use frequency, which is the number of time that document exists in the document to show the degree of importance of that keyword with respect to each of the document that we have. So they say, okay, we will introduce this term weighting. Okay. So in the term weighting, we basically look at the frequency. So we are looking at the importance of the term in a document. So this one, we can use frequency to tell that, okay, this document talk about quantum computing 6 times, or mention about quantum computing 6 times. So maybe quantum computing is more important in this document. So they look at the frequency of that keyword that exists in the document. Okay. So how do we formalize the concept here is we use this Wij, which is the weight of the keyword I in document J. So it must be greater than 0, meaning that they have some degree of importance. Okay? So if the keyword does not appear, so that means the weight will be 0. Okay? So in this case, they quantify the weight of each of the keyword in the document using the frequency. So based on this, they can use the number to quantify the similarity of the document and also the query that they have. Okay. So in that case, we will have a list of keywords that we have the vocabulary. So up to the T terms, T index term, and each one of them will have their punya own weightage. Okay, so we have the vocabulary. Each of the keyword will have the weightage for each document that they have. It should be 0 if not exists, and greater than 0 depending on how we define the weightage here. And each document will be represented as a vector of weightage of document. Okay, so the weight Wij of each term referring to the keyword I and also document J. So this is the concept that we're trying to put forward. Okay, so the earlier work, they're looking at the frequency of occurrence of the term within the document to represent the weight. So they just simply count how many times that keyword exists in the document. So over here, this one is basically looking at the total occurrence of keyword I in all the document. So this one is referring to number of document in the collection. So this is the total frequency. This is the frequency for each of the keyword in the document only. So capital I referring to the total frequency of occurrence of keyword I in the collection of all the document that we have. Let me show you the illustration here. Okay, for example, we have these 4 documents, D1, D2, D3, D4, and the document frequency Ni of a term Ki is the number of document in which it occurs. So, for example, if we're looking at the frequency of do in D1, so do in D1 we have 1 and 2, so 2. The frequency of do in D2 we will have 0. Do in D3 we have 1, 2, 3, 3. And do in D4 we have 1, 2, 3, 3 also. Okay. So if we total up this one, so this one will be the total number of occurrence for keyword do in all of the document that we have. So that one refer to this. Okay. And N refer to the number of document that consists the keyword do. Okay. So we only have 3, 1, 2, and 3. Okay. So so using this number of occurrence, we can fill up the weightage here for each of the keyword that we have. So based on this, then we can transform them into term document matrix. Okay. Okay. Any questions so far? Okay. 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 For this one, they are looking at the term correlation matrix. Of course, we have technique on how do we look at the correlation between term that we have. For example, we have this keyword, right? Or if we go back to the previous one, the matrix. Okay. Okay, we have all the keyword here. And now if we use the term weighting, so this F11 refer to the number of times keyword 1 exists in document 1, right? And similar to this, this is the number of times keyword 2 exists in document 1. So we can use this matrix in order to compute the how this keyword correlate to each other. For example, every time keyword 1 exists, keyword 2 also exists. So we can find out this one. Or every time keyword 3 exists, keyword 1 also exists. So this is the term correlation. We can find out that one using this matrix. Okay. So if we use this frequency to represent the matrix, and then we are here. So this term correlation matrix is used to find out how the keyword correlate to each other. Okay. So for instance, sometimes we have computer network or software engineering, they always come together, right? So we can verify this or validate this by using the term correlation matrix. Yeah. So for example, computer network, the appearance of one of these term attracts the appearance of the other, meaning that they always come together. Frequency here means how many keywords that are similar between document. No, we are not up to the phase where we quantifying the similarity yet. The frequency here is how many times that term exists in the document only, ataupun ya. Okay, so contohnya dalam ni kan, dalam ni how many times computer exists in this document, in this page. So kalau kita tengok 2 kali lah. So we only looking at the frequency of each word that we have in each of the document. So dia belum lagi matching with the query. We are not mapping the document and term, document and query. Belum lagi. Okay. 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 So since we have the term document matrix, so we can use that matrix in order to find out the correlation between keyword that we have. Okay, so this is, we want to form this term-term correlation matrix. Okay, so for example, to build this, we need to compute the correlation matrix, because the correlation matrix will tell us which keyword that always come together. How, what is the relationship between keyword that we have? Okay? So to compute the correlation matrix, which is this one, is basically looking at, no, this is referring to the vector of matrix that we have. So this is a term document matrix where we have T times N, where the M here referring to the weightage that we have. So matrix that we have, this one, this is our matrix, this is our term and document, right? So over here we have M also, but this is the MIJ. Okay, so we want to construct this term-term correlation, which is this one. So what we want to do is we take this matrix and we times with the transpose of this matrix. So this is the transpose of the same matrix that we have here. And each of the value that we have in the correlation matrix will express the degree of correlation between term U and V here. Okay, so this is the degree, how much they are correlated to each other between keyword U and V. And this is calculated as this one. Let me show you one example. Okay, we have this matrix, and with transpose, we get this, right? Okay, so we take the multiplication of these two matrices. So basically, we are taking this times this row column. So we multiply this plus this. So let me use different color. So the weight of this times this plus the weight of this times this. So that is only one part here. Okay? So this number will tell you how K1 and K1, but we ignore this part because we don't want that one. We want this K1 and K2. So if we replay this one again, so we take this, multiply with this. So basically we are looking at keyword 1 and keyword 2. Okay, so that one is we take this weight, multiply with this, so that is this one. And then we multiply the weight of keyword 1 in document 2 and also keyword 2 in document 2. This is keyword 1, this is keyword 2. Okay, so we have this. So this number represent the correlation between K1 and K2. Okay, so once we build this, then we have this matrix C. Okay, so that is the matrix C that we have here. So by looking at this number, we know which keyword always come together, meaning that high correlation term which has high correlation value. Okay, if we use the example that we have in the Boolean, for example like this. So this is our keyword. This is our document. So we take the transpose of this. Okay, so we take this, multiply with this, then we get of course here, but we don't care about that one. So we're looking at this times this, which is this. So 1 times 0, 0 times 1, we get 0. So we compute for each of these, then we get this. So this is your correlation matrix. Okay. So we look at the high number here. The high number here is this and this. So we are saying that keyword 3 has high correlation with keyword 4. Okay. Boleh. So that means every time keyword 1 exists in the document, keyword 4 also exists. So this is just a simple example on how to apply the term-term correlation. Okay. Any question? You want to take a break? 5 minutes? Biology break lah. 5 minutes, huh?
Okay, Prof.